if you put your fingers in the direction of 150 and you put your palm towards X, do you get your thumb pointing in the positive X or the negative X?
Yeah.
The positive X. So it's a positive moment. JJ?
I don't know, I just kind of,
You don't see it,
I'm
okay.
having trouble. Yeah,
Sure.
I would think it's gonna spin around the Y.
It will, it's gonna spin around all the axes.
Okay.
But right now, we're only calculating the force that spins around the X. Okay, we're only figuring out the spin about the X. It does have a spin about the Y too, and we're gonna do that next. So everybody put your fingers in the direction of the 150-pound force, put your palm towards X, the X axis, and is your thumb pointing in the positive X direction? It's positive, a positive spin. So what's that, 450? No, 4,500? 4,500 inch-pound, positive.
But isn't the 150-pound force going up?
That's correct. Remember that this is really, really, really important that when you use the right-hand rule, you do not care the direction of the force because you're taking an absolute value. You don't care what the direction of the perpendicular distance is. You don't care whether it's positive or negative, it's still going to come out to be positive because it's an absolute value. How do you figure out what the sign of the moment is? That's when you have to use your right-hand rule. So it's the absolute value of the 150. I don't care if the 150 is positive or negative. It's the absolute value of the 30. I don't care if that 30 is positive or negative. I multiply it together, and how I determine the sign is by using my hand. David.
Sorry, I missed why the Z is in the force category.
Oh, I just put it there to show that this force is in the Z direction. If the force is in the Z direction and the moment is in the X, that distance must be in the Y. Okay, let's try, let's do the 150 now. Mark? We're looking at the 150 now, but now we're trying to find the moment about, you know what, I'm going to put this up. Let me bring this down a little. So we figured out that the moment about the x-axis is the absolute value of 150 times the absolute value of 30. We found out that it's positive, so it comes out to be a positive 4,500 inch-pound. Okay, so now the question is, what moment is this force creating about the y-axis?
Could you draw that narrow circling the x-axis, which way is?
Sure. So this force is creating a moment like this
Okay, thanks.
around the x-axis. It's spinning that way. So if I draw it here, let's see. No. Does everybody agree with that drawing?
Yeah.
So I drew this in the front, and then the space here means that I see this and not this thing. This is like a hidden line. So it's going like this. Okay? Okay, so let's look at, so Mark, if we want to do the same thing with this, if the force is going up and I'm creating a moment about the y-axis, how should I draw my circle that I just drew there?
You'd want to have it be clockwise rotation around the y-axis.
Right, this force is trying to create a moment like this about the y-axis. So let's look at the distance. So we have the absolute value of the force, 150, times, what's the perpendicular distance to the y?
16.
16. The absolute value is 16. Does everybody see that? If the force is in the z, and I'm trying to find the moment in the y, the distance has got to be in the x, and sure enough, 16 is in the x. Huh? Say it again?
It works out differently.
Oh, okay, thanks. And now, Eric G, positive or negative? Fingers go in the direction of the force. Palm goes towards the y-axis.
Negative.
Is my thumb pointing towards the positive y or towards the opposite?
The opposite.
The opposite, so it's gonna be a negative, right?
Yeah.
And Peter, what did you say, 2400?
Yeah.
Okay, thanks. What? Why? So fingers go in the direction of the force, right? Fingers go in the direction of force. Palm goes towards the y-axis, and my thumb is pointing in the positive y is this way. If my thumb's pointing in the other way, it's a negative y. So let's get a physical feel for overall what's happening. This bar, this pipe, it's probably, maybe is it a pipe? It's a bar. It's probably pretty solid. Okay, so this is a bar here, and it's mounted to the wall. It's a fixed support. So I'm holding this here. And I'm applying this 100-pound force up, which is trying to cause this whole bar to spin around the x-axis that way and spin around the y-axis that way. So it's causing two spins so far. It's trying to get it to spin around the x, and it's trying to spin around the y. Okay, Chris L., what about the moment about the z?
So the moment about the z-axis, let's see, what's that perpendicular distance going to be?
Let's stop for a minute.
Hmm.
Remember when I used this example, that if I'm looking at the
Oh,
moment,
of
that's how
course, oh, what? It's parallel.
it's
So
parallel,
there's zero.
so it's 0.
Yeah.
Okay, so this example, when we try to find a moment about a point, if I had the force at this point, there's not going to be any moment. It could only be a translational force. It's not until I move the force away from that point that I could get a moment. But there's another scenario where you can't create a moment, right? I can't create a moment. 150 doesn't create a moment about the z-axis because they're parallel. There's no lever arm. Stand up and get trained. We'll go here. So I'm applying a force to Jill, right? That's along her arm, right? By doing that, I can't make this rotate, right? See, when I pull this, her body rotates, right? I'm pulling in this direction and her body is spinning like this, but her body is not going to spin along this axis because I'm pulling a force that's parallel to it. So there's no way I could create a moment about her arms if I'm just pulling in the same direction. This is parallel to that.
So the 150-pound force can only give translation.
It could only give translational motion in the Z. It can pull the whole bar up, but it can't spin the bar this way.
So for the answer on that one, would you just write parallel?
I would just write 0. So 0. And if you want, you know, let me do it here. Do you want to do one more? Do you want to do one more together with your, you know, pair up with someone? Let's do one more. So I'm going to zoom, I'm going to pull this thing down so you can see better. So do the 240 pound force.